Uh, Respected seniors from SGAT and delegates attending the session on online mode. A very, very good evening to all. First of all, I am very much thankful to our SGAT team, especially JM Das, JK Nanda sir, for giving me the opportunity to present our work. At the same time, I am very much scared to speak in front of them about DGMB, where a lot of stalwarts are there. I mean, who have spent their, in fact, years and decades in Eastern Ghat Mobile Belt. Actually, as Sayar was telling, actually, I have not much worked in Eastern Ghat as a field geologist. I have supervised a couple of STM items in Andhra Pradesh, as I was telling. And recently, I am supervising a graphite project that is the seventh major graphite belt in Odisha. And whatever I have learned during this compilation work, actually, myself and Makul Sab took up this compilation work. In fact, it's not a kind of your normal fundamental research kind of work. It's a compilation work where we have utilized the available GSI data from GSI Bukos and interpreted, analyzed, and you will find the outcome is quite interesting as we have not expected earlier actually while doing this work. So I am going with the presentation now. This is a graphite and manganese potentiality in the Eastern Ghats mobile belt contains parts of Odisha and Andhra Pradesh. So before going to the presentation, we have to understand the three marker horizons in Eastern Ghats mobile belt, and their disposition gives a clue to understand the geology regional structure. Those are graphite and manganese. Initially, we considered, myself and Marcus sir considered graphite and manganese as two marker horizons, and subsequently Jekananda sir suggested to include calcilicate rocks also into these three. Please bear with me. I have some coughing problem issues. So these three marker horizons, since these are essential part of high-grade metasediments, condensate group of rocks, and the idea is when these metasedimentary rocks have suffered polyphase deformation. So if we trace continuity of graphite and manganese, so we'll be able to understand the regional structure. I repeat, if we trace the continuity of the graphite and manganese, since these are marker horizons as well as calcilicate rocks, we will be able to understand the regional structure. And vice versa, if we understand the regional structure of Eastern Ghats mobile belt, which is quite difficult because structural data is not available. If we understand the regional structure of Eastern Ghats mobile belt, we will be able to understand the disposition of graphite and manganese and calcilicate rocks. This is the main idea behind this. With this basic idea, we take up this item and the interesting observation I will be showing you. So for that, what we did, we first actually GSI is what lot many we have done a lot of works in graphite and manganese in Eastern Ghats. So what we did, we digitized the graphite and manganese occurrences, old workings, pits, etc. We have considered around 87 reports, unpublished reports of GSI. Those are basically of G4, G3 or STM, some STM, some systematic geological mapping. And it includes 471 maps. This includes large-scale geological maps, detailed maps, STM, and systematic geological maps. First was digitization of graphite and manganese. Second data set we took from, these are structural data from Bukos application of GSI. We filtered the data because, and the database S1, S2, and everything is kept as foliation. We filtered the data according to our need. Third component is our digitization of structural trend line from Landsat images. That is basic thing that everybody does. while region that gives us the regional structure. So integrating these three data set, we identified crustal shear zones, which is based on truncation and transposition of foliations or termination of major folds that I will be showing in later stage, and identified 5 domains, lithotectonic domains. Also, we analyzed the foliations along shear zones, along the buffer zones of shear, buffer zones around shear zones, to identify, to study the nature of shear zones, and we correlated with the earlier observations. Also, we analyzed the data within the domain and broadly I tried to identify the kind of structure within the domain broadly. And integrating all these things, integrating our graphite and manganese occurrences, regional structure and structural trend line and available data, structural data, we try to identify zones which can be for further expression. In fact. So in that process, we have prepared 2 maps, that is structural tectonic map of Eastern Ghats mobile belt in 1:6 lakh scale that I will be showing in subsequent stage. That is in A0 size. We have composed it in A0 size. And graphite and manganese potentiality map of Eastern Ghats mobile belt in 1:6 lakh scale. This is our outcome of our study. One is tectonic elements of Eastern Ghats mobile belt, where we have shown the behavior of structural fabric in entire Eastern Ghats mobile belt and structural fabric along crustal shears as well as within the identified domains. Second is graphite and manganese potentiality, where we have shown the disposition of graphite and manganese with regards to the structure, and we have identified prospective areas for exploration. So before going to that, this is the very fundamental map that is a comprehensive map available for Eastern Ghats mobile belt, that is by Ramakrishnan et al. We have taken it from Geology of Odisha. So before going to our work, actually I'm just briefly describing some research work carried out in Eastern Ghats mobile belt, which I have classified into these 4: tectonic evolution of Eastern Ghats mobile belt, alkaline magmatism, deformation and metamorphism, economic geology aspect. And the tectonic evolution, with regards to tectonic evolution, that everybody knows, that starts with Nanda and Patisha, Ramakrishnan et al. So many works has been, and still the work continues in Eastern Ghats mobile belt. And our work, but with regards to economic geology, the work which so far we have seen our research was those pertains to manganese, graphite, and apatite occurrences, their genesis in a particular prospect or particular deposit. But our case is again, so because our that first map, that is tectonic element, tectonic map of Odisha we prepared. So before that, I'm just going to briefly describe what are the ideas that these were existing since long regarding classification of Eastern Ghats mobile belt. The first and foremost classification that is given by Nanda and Patti, that is basis of 300 kilometer long transit across EGMB, and they have classified the Eastern Ghats into main 3 zones. These are given here: Eastern Migmatite Zone, Central Condylite Zone, and Western Charnockite Zone. And subsequently, lithogenation was done by Krishnan et al. They have classified the Eastern Ghats into 4 longitudinal zones: Western Charnockite Zone, it's here, and Western Condylite Zone, Central Charnockite and Migmatite Zone, and Eastern Condylite Zone. This is Sileru Shear Zone. West of it lies our Western Charnockite Zone, and east of it lies Western Condylite Zone. Then this is Central Migmatite Zone and Eastern Condylite Zone. And this is Godavari Graben. And our study area lies north of Godavari Graben up to Shukinda thrust.
देखना है तो
The second,
wait.
one more classification that is given by Rikas et al. They have given it, they have classified the EGMB into 4 crustal domains based on available isotopic data. These are the 4 domains. Domain 1 and 1A and 1B that corresponds to Western Chanakite zone of Ramakrishnan et al. And domain 2 that is almost Eastern Condylite, Western Condylite zone. And domain 3 that is almost Central Migmatite zone. And zone 4 that is yes, zone 4, domain 4. And subsequently, Chetty and Murthy, they have classified also. And their ideas is EGMB is considered to be a collage of several juxtaposed terrains separated by major shear zones. They have identified around 13 or 14 shear zones over here and divided the Eastern Ghat into different blocks. The map is given here. And subsequently, Dubmeyer and Rath, they have again classified the Western Ghat Mobile Belt East EGMB into 12, in fact, domains and 4 provinces. These are Krishna province, Eastern Ghat province, and our study area lies similar to our Eastern Ghat province, Jaipur province, and Rangali province. These are the 2 maps for comparison. And this is our tectonic or element tectonic map, where we have classified the Eastern Ghat into 5 lithotectonic domains, and our study area lies north of Godavari Graben up to Sukinda shear zone. These are the 5 domains: Angul Redapur domain, domain 2 Balangir domain, domain 3 the Spola Pudwali domain, domain 4 Nagavali Vangsadhara domain, domain 5 that is Vijay Nagaram and Rajamahendravaram domains. I'm just giving the details. Starting from northward, this is domain 1, ungulated Redapur domain. This is Sukinda thrust or Sukinda shear zone. The area domain 1 that lies south of Sukinda shear zone and north of Mahanadi shear zone and lies west of our Riyama shear zone. That is domain 1. It's Angor Redapur domain. And domain 2 is Balangir domain that lies west of our terrain boundary shear zone and east of terrain shear zone and west of tail shear zone. And domain 3 that lies south of Mahanadi shear zone and north of Vamsadhara shear zone. And domain 4 that is Nagabali Vamsadhara domain that is lies west of Vamsadhara shear zone and east of Nagabali shear zone. And domain 5 that is south of Nagabali shear zone and east of Sileru shear zone. These light green colors are disposition of graphite bands actually. There are prospective areas that I will be discussing in detail. And these purple are manganese prospective areas. Sir. Now that is part 1 hour, that is structural and tectonic elements of different domains of Eastern Ghat mobile bed. How structure is behaving, that I will be describing in detail. And Sukinda south of Sukinda shear zone, here the myelinatic foliation. Here the myelinatic foliation is our Sukinda shear zone. It's a southerly dipping myelinatic. It is southerly dipping myelinatic foliation, and the myelinatic foliation is 80 degree towards 182. It's 21 number of data we have taken and analyzed. It is means southerly dipping plane, and it is Mahanadi shear zone. It's a northerly dipping foliation, myelinatic foliation that is 50 to 50 degree towards 14. Actually, we have done structural analysis. This is the outcome of structural analysis, and within this domain, the foliations we have analyzed 522 foliations data we have taken and analyzed, and it gave beta axis that is fold axis 27 towards east, means It's generally that detail with structural data will be showing in our exercise map. In this part, all the folds are easterly dipping, easterly plunging, in fact. And this is domain 2, lying west of tail shear zone. In this part, it's a fold thrust belt is described by Biswal and Sinha. The domain is traversed by northwest-southeast trending to large-scale lateral ramps, that is bicameral lateral ramps. That's a Biswal sub, bicameral lateral ramps, and our Turkella Clippe, lateral Nape are there. Career lateral ramp. This is that area. In this part, the beta axis of around 139 data, it is showing beta axis, fold axis, 62 degree towards 118. In this part. Oh no, that is beta axis is 43 degree towards 116. This is the beta axis. All the folds in this part are easterly plunging almost. And in this is domain 3. This is lying south of Mahanadi shear zone and north of Vansadhara shear zone. And in this part, the structural data analyzed, we have that calculated beta axis is 59 degree towards 335. Means all the, it is around 1935 data we have analyzed. And statistically, the statistical beta axis is towards 59 degree towards 335 in this part. It's northwesterly plunging folds. It is another domain 4. It's lying west of our Vansadhara shear zone and east of Nagavali shear zone. In this part, 696 data we have taken. It is showing fold axis towards 72 degree towards 147. It's southeasterly dipping plunging folds in this part. And coming to domain 5 here, it's lying south of Nagavali shear zone and east of Silaru shear zone. Silaru shear zone, if we see the structure that I will be showing in subsequent maps, right east of and west of our Silaru shear zone, all the foliations are easterly dipping. And in this part, the major folds are the beta axis we have analyzed for 4,458 data. We have analyzed and it is giving the beta axis 62 degree towards 142, means southeasterly dipping plunging folds, all that. So it contains southerly plunging folds informal structure, and these are the graphite vents, how they are being. I will be discussing in detail. This is the regional geological maps showing different domains. And now we'll be discussing the disposition of graphite and manganese different domains of standard mobile bed. This is domain 1. In this part, if we see this, these are the area Thakurgad, Pakharkata, Adeswar, Gobindpur, Mindol. These are the areas. These light green colors mean small blocks are where GSI has reported graphites in this part. And based on the structure, regional structure, we have identified prospective areas which can be taken up for further exploration in this sector. It's in fact, GSI is presently carrying out in this area. And if we do detailed study with just keeping the structure of data in view, we'll be able to we will be do justification to the exploration process in this area. So Lathi, you can see it's south of Paredakol Mindol Fault and north of Mahanadi shear zone. In this part, if we see the folds in this part, it's southerly plunging folds. And in this way, just parallel to Mahanadi shear zone, all the foliations are becoming parallel to our Mahanadi shear zone, this part. We'll be visualizing this better way in exercise map that I'll be showing at last. Actually, I'm just showing the disposition of graphite and manganese in different sectors. with regards to a structure. And these are the structural data, and these are the lineage, right, gray colors. And again, it's in Panimara sector. If you see the structural distribution over here, this is easterly plunging synforms and antiforms are there. Synform and subsequently towards south, it's antiform. This is the light green color in Panimara area where graphite has been reported. If we see the regional structure in this part, in certain parts, it's giving a dome and basin kind of structure, means superposition of folds. And in this part, if you see, it's a easterly plunging fold. So, following the regional structure, we can take up our exploration item in these areas, as it is corroborating with the regional structure. This is another area, Samal area, Angul district. Recently, Mahakul sir beginning. In fact, it is a validation of our model. In this part, if we see the graphite veins are parallel to our Sukinda thrust zone, which is almost west, northwest, east, southeast. It's a new finding, and GSA is will be taking up item and in 24-25. This is in domain 1. And regarding domain 2, it's in fact Bargad, Atrada, Balikhamar, Laramba sector, Balangir district. This is the area. Here, if we see structural data also, it is showing a easterly plunging macroscopic fold. And earlier fold also we are having here. In this part, if we see Harrier lateral ramp, it's lying southwest of area. And south, towards south, the foliation is almost northeast, southwest. And towards the edge, approach to career lateral ramps, it's becoming northwest, southeast. Just because of that career lateral ramp. In this part, all the foliation almost goes parallel to the terrain boundary, and foliations will be finding easterly dipping. And its a major fold is almost easterly dipping. No, easterly plunging. And you will get graphite at the periphery of Gandhamardan bauxite plateau. Here is the Gandhamardan bauxite plateau. And at the peripheral part of this, we will be getting graphite. These are small dots like things or rectangles are graphite. The reported occurrence of graphite, we have identified this zone, and lot of work has been carried out in this part by GSI. Some of the areas is Turekala, Bagdor, Lathor, Darlipali, Salepali, and Patnagar, Luasinga. The Sargipali area, this is Sargipali belt actually, Rengali. These are the areas where GSI has already long back taken up graphite exploration project item in this area. Then this is another area in the same Kuiripani, Laramba sector, Tamia sector, sir, Dungripali, Khatsaval, Thakurpali, Salepali. These are the areas where we are getting manganese, in fact, in this area. And if you see the structural distribution in this part, actually it is giving a dome and basin structure over here due to superposition. And manganese is occurring at the periphery of the area. It's a complex terrain, so we need to understand or you need to study the structure in detail. We have used the available structural data of Geological Survey of India. So further detailed study can be, because it's quite regional scale, and further detailed study, large scale mapping kind of things can be taken up with this area to understand the regional structure as well as the disposition of manganese or graphite in this area. Another important part is this. In this part, if we see a fault parallel to our Turkey, that is career lateral ramp, we'll see the graphite towards west is juxtaposed over the manganese. It could be only due to the faulting. And these all are westerly dipping faults plunging, external plunging faults are seen in this area. So again, what can be taken up in those areas also. In another sector, this is the two. Here we can the Spurla graphite belt. It is a new finding, and where it's covering around 700 square kilometer. We have so far covered around 7 square kilometer. In this part, if we see, it's westerly plunging antiform and synform. In towards north, we see the fold is truncated against the Mahanadi shear zone. Means, in fact, it is a dextral, it's this asymmetric fold is giving the dextral sense of shearing along Mahanadi shear zone. So, around in this part, we have just completed one around 3 square kilometer in this area. That is Tumandi Graphite Prospect. It's the seventh major graphite belt in Odisha. At it's around 3 square kilometer we have covered, which yielded around 3.83 million tons of graphite with average grade of 3.87. This report is recently circulated, and it also contains a vanadium of 750 kg. And in work is under progress by Geological Survey of India. And rest of the items we have taken up G4 items in this area, and we'll be identifying more zones in this area. And you can see some of the location of graphite where fixed carbon content is given 17%, 10%, 21%, 22%, 12%. With Tarini process, he has collected several samples outside his study area, and based on which we have prepared this belt. In fact, it's the Spalla graphite belt. It's the seventh major graphite belt in Odisha. So in this, I'm just showing some geophysical, how SP, self-potential geophysical survey we have used. And it is corroborating well with the graphite, and the black colors are graphite bands, which has been projected from the drilling data. We wanted to correlate with the SP geophysical survey. The negative SP geophysical survey, it's a positive indication of graphite. So if you see these areas, those are to the tune of -200 to -500, something like that. So a negative SP anomaly is positive indication of graphite bands. So if we understand this area, it's a total width is around 2.5 kilometer. If we see the bands within a width of 2.5 kilometer, there are 5 to 6 bands are there. Those are parallel or subparallel. And in between, we have the distance of gap of around 200 to 300 meter interval. And each band contains several parallel, subparallel bands with pattings. So the interesting thing is that in the Tumandi graphite, what we have resource has been established based on 5 occurrence and 5 pits and couple of trenches. We have established the strike length of the graphite up to 4 kilometer. Similarly, in Tumandi East Graphite Project, based on only one BRS sample, with systematic planning of boreholes, we have established the strike length up to 2.5 kilometer with couple of trenches, because the area is entirely soil covered. So if we follow the regional structure, my intention is to that if we understand the structure of the area, because though graphite is litho-controlled, but the disposition of graphite and manganese is controlled by structure. So if we follow the regional structure and or local structure in that particular area, simply you go by the strike, following the strike of that bed, without giving the trenches also, if we meticulously study this part and follow the strike, we will be encountering graphite and boreholes actually. So this is my idea. So this is what I wanted to speak on this slide actually. Coming to domain 3, and there are some Boirani sector, some manganese bands are there. The either side of these are prospective. We need to again follow the follow the regional structure, and so to understand the regional structure and structural local structure also in mesoscopic scale. If you see the Tumudi sector, it's a graphite band. Tumudi actually it has been mined to some extent by earlier. It has been mined. So if you see the regional structure, it's following a southeasterly plunging. It's southeasterly plunging antiformal structure, which graphite is. This is the disposition of graphite. So if we follow the regional structure, we can get the graphite vents in these areas. So, and the foliation towards west, it is a transverse parallel to the Bangsadhara shear zone in this area. It's domain 4, it's lower Padar, country sector. If we trace from the northern part, light green color, these are graphite bands actually. If correlated, if we can trace the axial trace, we can do it up to down south. It's a southerly plunging. In this part, we are seeing some dome and basin kind of structure. Because detailed structural data is not there, but it is giving a circular to elliptical outcrop. So graphite is occurring like this. So in this part, our approach, that's why we're emphasis to do detailed study on structures in this area, so that we'll be able to understand the disposition of graphite and graphite beds in this area. So these are the disposition of graphite in this area actually. So several, and these are open on all the ends, in fact. So you need to study in this along the strike direction, following the regional structure. Again, this is a Sanamunda, Naringa Panga areas here. Director of Geology and Mining is doing work in this part, I think. Sarviguda area. It is a southerly plunging synformal structure, and the graphite, these are the disposition of graphite bands. Further south, this is the F3. These are again very folded by next generation folds. This is another sector lying south of tail shear zone. In this part, a quite interesting thing is that graphite band lying north of this is truncating against the tail shear zone. And towards south of tail, all the manganese and graphite bands are parallel to the tail shear zone. So it's almost a northeast-southwest trend. And towards it, we can see just half C kind of thing we have given. Actually, it will be, these will be actually again a domain basin structures. We have conservatively extended this up to this part again. But if we do detailed study in these areas, again it will continue like this, according to our observation. Actually, we can do the Excel trace, do the drawing of Excel trace over like this. And again, it's in another domain 5. This is a mostly explored area. We can see Somalia, Dumsi, Ichapur, Kanwa, Kalupuram, Devsola, Mandara, Kutinga. And these are the areas where both graphite and manganese is occurring. In this part, we can see these are the graphite, the green are graphite and purple are manganese. This is following the regional structure in this area, if you see. All are trending northeast, southwest. And but in this part, we are getting graphite and manganese both. And these are the graphite is competing against our manganese. This could be partially a fault that we don't know, but we need to do further study in those areas. In fact, we have to do field work in this area. This is the disposition of graphite and manganese in this area. So along the strike continue towards south, this can be explored. These are the area of greenfield. These will be greenfield areas towards south where exploration can be taken up. And coming to our Garham Garibudi area, It's a southerly plunging synthermal structure. This red, purple color, our rectangles, these are the reported occurrence of manganese. So, in these gap areas, following the regional structure, we can take up exploration. We need to revisit those areas and need to follow the regional structure. Again, there are several bends towards south of this also. There are certain area, Burugabanda, Tapsikonda area, graphite and apatite also reported. You could see how the asymmetric fold, the graphite is forming an asymmetric fold and it's following the asymmetric fold. These are light green colors are reported occurrence of graphite. And towards west, and Koppakonda will be having some basinal structure with axial trace. Letter is one is northeast southwest and another is northwest southeast. So our it's actually objection is that there is a huge tract of area between our. This is our northern part. We have Taldosi, Upadosi, Putting and Iskal area, and towards south we are having Burugumanda, Tapasikonda area. If we see the regional structure in this part, actually, it's parallel to our silver shear zone, and these are the gap areas where expression for graphite, not all the areas, but starting from one end, we can take up following the regional structure for graphite expression, this area. Towards north from Nishikal, putting a Nishikal area, we should come further south, and from Burugavanda, Tapasikunda area, we should move towards north by for graphite expression. These are the gray areas where expression can be taken up. So these are the observations which I have already discussed, and these are the some areas we have demarcated which can be taken up further exploration. These are the already discussed high continuity in the Dandatappa belt, Panimara area, Garnamardan range, Daspalla belt, Tumdivanda belt, Sariyuda Naringapanga areas, Puttinga Nisikal belt, and Boirani belt, Garvam Garividi belt that I have already discussed. Now I will be showing some that geological map. That's a map will be able to understand and clear way actually. This will be a seamless map in A0 size where we have given the names of topographic numbers also. From north we are approaching. This is our sir. Is the map visible, sir?
Yes, yes, it is visible. Yeah, yeah.
Yes, sir. Yes, sir. Then starting from north, this is Sukinda Sierjan. This is small area, sir. You see the regional structure, it's following northeast, south, northwest, southeast. It's parallel to our Sukinda shear zone. In between, we have Gondwana rocks. This is our Ghodadiya area, Panimara Ghodadiya area. You see the regional structure, and the regional structure is here in this part, plunging southeasterly. And our statistical beta axis was also plunging towards south. And all the data also supporting to plunge towards southeast. Okay, this is our north of our Mahanadi shear zone, Kollamal area, Taldar, Akharkata, Thakurgarh, Mindol area. You see the regional structure in this part. These all the bends are parallel to the Mahanadi shear zone, and which are affected by lateral folds also. And the foliation, if you see in this part, it's easterly, southeasterly plunging folds statistically. Of course, you can do sector-wise analysis to have better idea about the local structure. But this analysis, it gave us the rough idea about the regional structure within the domain. That's what idea, because it's very hard to deal with thousands of data. We've just put these blue ones are actually foliation data, and the gray lines, dark gray line, these are structural trend lines. And we were given the toposit numbers for better observation actually. Now we are coming to domain 2. Here we see the disposition of graphite in this part and manganese in this part. Here, how a fault is bringing graphite band and manganese band together. This is the career lateral ram. In this part, if you see, all the foliations are dipping southeasterly. And career in this part, actually, sir, if you see, it's a bulging kind of thing. So this block has been transported more compared with to the rest of the blocks, actually. It's a bulging kind of a convex towards west kind of thing. The situation is there. This is tail shear zone. If you see the disposition from manganese and graphite along tail shear zone, it's parallel to tail shear zone towards south and towards north, where it is truncating. So it's a shear zone. That structural analysis I've already told, sir. Now, if you see this part, now we are coming to the domain 3. This Mahanadi shear zone, how this foliation is, the entire fold is truncating against the Mahanadi shear zone. It can be beautifully visualized here, and how the structural data is supporting this regional structure also. And the disposition of graphite also in this part that you have taken up for action. But towards south, we have not studied how where it is going. It's likely to discontinue along Rusicula shear zone here over here. This is our Tumandibandha sector. This is how this southerly plunging fold it is parallel to the western limb is parallel to the Vansadhara shear zone. Means how beautifully this graphite band is disposed. Now we are coming to domain 4. This is a quite complex area in this area. So these are dome and basin kind of structure exists over there with north-south axial trace. These are the manganese band you see. If you continuously, you can trace the manganese bands lying west of graphite here. But in this part, along tail shear zone, both and manganese and graphite occurs together, according to the available data actually. But in this part, towards west, we have manganese continuously, and further east, we have graphite, which have been deformed into some kind of dome and basin structure. And coming to domain 5, actually, this is the Fulbada Raigada area, Nisikal putting area, manganese and graphite. Kalibala, Domsil, Ichapur area, Maliguda area, here, graphite and manganese occurs in this part. Topostic numbers are given. And here, these are the Garham Gravity manganese belt. How beautiful the structure is shown. It's a southerly plunging informal structure, and how the manganese are disposed. So you can continue take up exploration items in those areas. Coming further south, this is Burugumanda Taptasikunda area, and this is the gap area which I was discussing about between the Sikal area and Burugumanda Taptasikunda area. We can take up exploration systematically, starting from Burugumanda area towards north, and from there we can approach south. And sir, this just see the towards south of east of Sileru region. All the formation about 50 to 100 kilometers width, all the formations are tracking in dipping towards southeast. And we have also in some of the works we have seen towards west of Sileru region also up to certain kilometers width. All the foliations are also dipping towards south. This is the effect of the thrusting. Not only so, ciliary region is just a line, but the effect of thrusting is observed quite far beyond the established ciliary region. So we have in this map we have given the data of each domain and each region. These are the results. So I'll just okay. This is all about my presentation, sir. Any suggestions, please?